Hi guys, I'm recording this slightly differently to I usually do for your worked solutions because I want to be able to show you how I use the formula book as well as working through the exam paper as I go. As I work through this, obviously if you've got a question completely right, there's no need to watch through that question, so you can skip through. But as I go through, I'm going to be doing two things. I'm going to be working through the paper kind of working out the answers and telling you my thinking and kind of the maths behind it. And at the same time, I'm also going to be talking through how to get maximum marks, kind of where to pick up marks, where some of you lost marks. So even if you got a question right, if you've got the time, it might well be worth watching a question through anyway, because there could indeed be something to learn from it after all. So let's get started. The first thing I actually want to say before we get going is that you had 5 minutes reading time at the beginning of this paper. Now, there's not a lot you can do during the reading time. Obviously, you can't write on the paper or kind of get going with any questions. But I think the most important thing to do in that 5 minutes of reading time is to look through and identify the questions that you think are going to be easy and kind of maybe make a note in your mind of those ones that you're going to start off with. Also make a note of the harder ones and really have a read and a think about those if you've got the time, because your subconscious will be kind of working on the questions as you go, even when you're not kind of physically looking at them. So one, identify where you're going to start. You certainly don't have to do the paper in order. And identify which ones are going to be the ones you know you're going to struggle with and you want to be able to have a kind of background think of them as you go. The other thing I noticed was that a few of you left the exam early. Now, that I tenuously understand it in a mock exam. I don't really think it's a good idea at all. But if anybody leaves the real exam early, I am going to be stood outside that door and kick you back in again. Do not leave an exam early ever, but particularly not my maths exams, because maths is something that needs time to settle in and think about and solve. There'll be some questions on your paper you can do straight off without thinking about them. But there's also going to be questions that you look at, and when you first look at them, you've got no idea. And that's okay. That's the nature of an IB exam. It would be weird if you looked at every question and knew exactly how to do it. But you've got to give yourself time and a chance to figure it out. So have that resilience, sit there through till the end of the exam. The worst that happens is you spend 20 minutes doing nothing, you'll get over it. But if you leave, the worst that happens is that 5 minutes after you leave, you work out the answer to a question, and that would really be awful. So definitely sit there through till the end of the exam. Right, okay, now I've given my kind of, my big picture things. Let's get started. So this first question, it tells us a function and it asks for this. Now this is a piece of content information you just need to know. That's asking for the inverse function. And there is a method to find an inverse function. My tip would be work it through step by step. Definitely don't kind of do it all in your head, because that's when people make mistakes. But we know that when we're working out an inverse function, we swap over the x and the y. At the moment, there's no y there, but we can rewrite out f of x equals something to y equals it. So y equals x minus 5 to the power of 3. We then swap over the x and y with each other. So now we have x equals y minus 5 to the power of 3. And then we want to rearrange this again so that it's in the form y equals. Now, this is the part where I saw people make mistakes. They just kind of went in their head like, oh, there should be a plus 5, there should be a cube root. Don't do that. Instead, think about the order of what's happening to the y and undo it. So y is having 5 subtracted from it, then it's being cubed. So that means if I want to undo this, the first thing I'm going to do is cube root both sides. So that will leave me with the cube root of x equals the cube root of this which is just y minus 5. And now I'm going to add on that 5. So that will give me the cube root of x plus 5 equals y. Now that would get you full marks, but a nice touch here would be to now replace that y with the f inverse. So f inverse of x equals the cube root of x plus 5. In terms of where your marks come from, swapping over the x and y gets you a mark, so worth doing even if you're not sure where to go from next. That's also why you shouldn't just skip forward to a final answer. So swapping the x and y gets you a mark. Doing something sensible in the middle here, like a cube root, and then, you know, sort of heading in the right direction gets you a mark, and then a mark for getting it fully correct. Right, next question. So for this question, it says we have an arithmetic sequence. We know the third term and we know the fifth term. The first question asks us to find the common difference. Then we're finding the first term. Then we're finding the sum of the first 20 terms. Now, it's really worth reading through the entirety of a question before you get started with it, because sometimes they kind of lead on from each other. And so you can start to think about the structure of the question and what they're trying to achieve there. So, for example, I know that if I'm looking for the sum of the first 20 terms, actually I'm going to need the common difference and the first term. So my answers to these are going to help me with part C. Right. The next thing I'm going to do is I notice it's an arithmetic sequence. I know there are formulas in the formula booklet for arithmetic sequences, and I'm going to find those now so that I'm ready to go. So I'm trying to figure out which section it's going to be in. I mean, sequences, it's either going to be functions or number and algebra, not prior learning. Here we go. So we've got the nth term of an arithmetic sequence and the sum of n terms. And I make sure I'm going for the arithmetic sequence and not the geometric sequence. So I'm just going to have that open and ready in front of me as I continue to work so that I can use those formulas. Right, the next thing I'm going to do is start kind of labeling up some of this information. So for example, the third term is 10. Well, that's telling me U3 is 10. I'm just putting it into mathematical notation. And I know U5 is equal to 16. It's asking me to find D, to find U1, the first term, and the sum of the first 20 terms of a sequence. So that's when they've been added together. And then if I take a look here, it's definitely obviously that second formula. They've even used the same wording, the sum of the first so many terms. So we're not looking for U20, we're looking for S20 instead. Right. Having a look at this, there's a couple of different ways I could work this out. I could start substituting these into formulas and using simultaneous equations, but I'll be honest, that's kind of overkill. I know what a arithmetic sequence does. I know that there's some common difference, some common number that's added to get between them. So I know U3, there's U4, which I don't know, and I know U5. So I know this one's 10, I know this one's 16. I know there's going to be two common differences added on to get between them. So if two common differences is a jump of 6, one common difference is going to be a jump of 3. So my first answer is that D is equal to 3. Then I want to work out what U1 is. Again, I could use a formula, but for numbers this low, it's kind of overkill. So now I know that D is equal to 3. I know I can subtract 3 twice to get back to U1. So this will be 7, and my U1 will be equal to 4. Right, now I've got those two figured out. The final question says the sum of the first 20 terms. So I'm looking for S20. And the first thing I'm going to do is just copy out the formula from the formula booklet. Actually, no, it's not. The first thing I'm going to do is look and see that there are actually 2 formulas from the formula book, and I'm going to think about which one's most useful to me. So the first formula uses n. Well, I know my n is going to be 20. It's the 20th term. It uses u1, which I have, and it uses d, which I have. On the other hand, the second formula uses u1 and un, so I would need to know u20. Now, I could figure it out using the un formula, but considering I don't already have it, I might as well use the formula that uses the information I've already got. So this is the formula I'm going to use to complete this question. So I've got n over 2, 2u1 plus n minus 1 times d. And now I'm going to fill in everything I know. So I know n is equal to 20. I know d is equal to 3. Oops, that's a minus 1 and there's a 3 here. That's over 2, and we've got 2 times u1, which is 4. There we go. And I'm just going to double check it, make sure I've made no mistakes, make sure I've not lost that plus, which a couple of people ended up doing. Just double check it, take your time, because it's, these are the easy questions you should be getting full marks on. So don't lose a mark on a silly error. Right, after that, it's a non-calculator exam, so I'm just going to take my time working it through carefully. So 20 divided by 2 is 10. 2 times 4 is 8. And then I've got 20 minus 1, which is 19. And that needs to be multiplied by 3. So 19 times 3, there's a couple of ways I can do that. I'm going to do 20 times 3, then subtract 3. So that will give me 57 for this value here. So 57 plus 8 times 10. 57 plus 8 is going to be 65. So it's 10 times 65, which is 650. Again, don't rush this. These are easy marks, but the worst thing you could do here is, multiply 19 and 3 incorrectly and lose a final mark there. So think about where your marks come from. There's probably some kind of method mark in here for each of those because they're 2 marks each, but it's mostly just for getting through to the final answer. Here, you get a mark for, not for picking the correct formula. I mean, it literally is just reading out the formula booklet. But this stage here gets you a mark. So if you've substituted your values correctly into the formula, you pick up 1 mark. If you manage to do some working that correctly simplifies it, kind of maybe down to here, you get 1 mark. And then you get your final mark for having the correct final answer. Right? Next question. Okay. So first thing I'm going to do, I can see there's a lot of writing, there's a tree diagram. I've got 2 questions here, so I'm just going to read through it carefully. So it says the probability that it snows today is 0.2. And I can see here's snows today and 0.2. So that information is already here on my tree diagram. If it does snow today, the probability that it will snow tomorrow is 0.6. So it snows today, then the probability it will snow tomorrow is 0.6. That information is also on there. If it does not snow today, the probability it will not snow tomorrow is 0.9. So if it does not snow today, the probability it will not snow tomorrow is 0.9. So that means this probability here is 0.9. And then it says, using the information given, complete the following tree diagram. So the information, the content that we need to know here is that with a tree diagram, each V should add up to 1, or if there's 3 of them, all 3 in there should add up to 1. So the probability it snows today is 0.2, then the probability that it doesn't snow today is 0.8. And then each of these ones should add up to 1 as well, because after it snowed today, then the probability it snows tomorrow is 0.6. So the probability it doesn't snow tomorrow is 0.4. And the same over here, these two should add up to 1. So this is going to be 0.1. Great, I've got my 3 marks there for filling in the tree diagram, not too crazy. The next thing we need to do is calculate the probability that it will snow tomorrow. So here's where we're looking at snowing tomorrow and snowing tomorrow. But how do we get that total probability that it will snow tomorrow? Well, there's 2 different ways it can snow tomorrow. Either it snows today and then it snows tomorrow, or it doesn't snow today, but then it snows tomorrow. And so the probability it snows today and snows tomorrow is going to be this probability multiplied by this probability. So 0.2 multiplied by 0.6. And the probability it doesn't snow today but does snow tomorrow is 0.8 times 0.1. And then our total probability that it will snow tomorrow is those 2 added together. Now, writing that out is going to get you 2 marks out of the 3 if you've done it completely correctly. The final mark comes from being able to multiply decimals together, something that I think some of you need a little recap of. Let's start off with this one because I think maybe it's easier to think about the place value here. If we're multiplying 0.8 times 0.1, it's definitely not going to be 0.8 because that would be keeping it the same size, and it should be getting smaller if I'm multiplying it by something less than 1. So this multiplied together is going to be 0.08. Also, one way that I like to think about it when I'm multiplying decimals is if there are 2 decimal places in total here, there should be 2 decimal places in total here. That's the method we're going to use to multiply these 2 together. So we've got 0.2 times 0.6. 2 times 6 is 12. But where does the decimal point go? The decimal point should go, well, there's 1 decimal place here, another decimal place here, so 2 decimal places. The decimal point should go there. Then I can add them together, and 0.12 plus 0.08 is 0.2 in total. Some things to watch out for. If you're calculating a probability and you end up with a number greater than 1, you've gone wrong. So for the people who wrote 1.2 here, that can't possibly be a correct answer because all probabilities should be between 0 and 1. Otherwise, 0.2 kind of sounds reasonable. Anything too small would be unreasonable because there are some fairly high probabilities it will snow tomorrow. 0.2 feels like a correct answer. And hopefully by now you guys know how to multiply together decimals. Right. Number 4. Aha. This is one that a lot of people struggled with. I think I only had 1 or 2 correct answers here. There are a few different ways to approach this question. I'm going to show you a way that feels kind of maybe more like it kind of translates across different possibilities, maybe slightly easier. And so it says, the following diagram shows a right-angled triangle. Okay, right-angled triangle. As soon as I see that, I'm thinking, why are they telling me it's right-angled? Well, if it's right-angled, I can definitely use SOHCAHTOA with it. So I'm just going to write that out. Just think right-angled, it could be SOHCAHTOA. It tells us that sine A is equal to 5/13, and it asks us to show that cosine A is 12/13. Now, be very careful with a show that question because they have already told you the answer. So you don't get any marks for writing that answer because you've already been given it. So then, how do you get the marks? You get the marks from your process of moving from this question to this answer. So you need to start with this information. You cannot use what you're trying to show it. That's called circular logic, and it's rubbish mathematically, so don't do that. So we can only use this and formulas we know to get to this answer. You might wonder, why do they tell me what the answer is? 1, I suppose it helps you kind of get there a little bit, and that's nice. It's only a question 4. They're not trying to kill you off just yet. The other reason that they would use a show that question is if the next part of the question is going to use that answer and they want you to be able to kind of carry on with the rest of the question. And again, that's a typical thing to do around question 4. By the time you get to some of the crazier questions like question 7, question 10, they're not that nice. They'll do things where you need to be able to work out something correctly and be able to use it further on. But here, if you're ever finding a show that question, it's definitely going to be an answer that's used somewhere later in the question. So keep all of that in mind as you work it through. Right, so then the question is, how can I show this? Well, we know sine A and we're trying to find cosine A. So I'm going to pull out my trusty formula booklet and I'm going to search through for any formulas that involve sine A and cosine A and see what I can do. Nothing with sine A or cosine A there. Here we go, we're starting to get to some trig formulas here. But as I look through, the sine rule only uses sine, the cosine rule only uses cosine. That's something about the area, definitely not relevant. Let's keep looking. Aha. So here we have a bunch of identities. And I could pick any one of these identities. These are things that are always true for trigonometric functions. But I'm thinking back to my question, and my question had a sine and a cosine in it and nothing else. So I don't want to use this one because it involves tan. This one only uses cosine and sine, looking handy. This one has sine and cosine, but also has a sine 2 theta, and we've not got that right now. And I'm just kind of spotting this down here, this cosine 2 theta, and I'm thinking, yeah, that might come in handy for the second part, but I'm not using it yet. So this is the only formula that only uses cosine and sine. So that's the formula I'm going to use to help me with part A. So step 1, I'm just going to copy that out. So cosine squared theta plus sine squared theta equals 1. Right, what have I got here? Well, the thing to kind of recognize here in the piece of information to know is that cosine squared theta is the same as saying cosine theta squared. So it's like squaring the whole thing. And the same here, sine squared theta is the same as saying sine theta squared. And then those together equal 1. Now, be very careful. I don't want to be substituting this into this formula. That should be my final answer. But this piece of information up here, that's something I can use in my working. So I know sine A, or theta A, they're both the angle, is equal to 5/13. So the entire thing, sine A, is equal to 5/13. So I'm going to replace this with 5/13. There we go. Now I want to figure out what this is. Again, I can't jump straight to here. It's already told me that that's the answer. So instead, I need to work this through to figure it out. The first thing I'm going to do is I'm going to square 5/13. And that's going to give me 25/169. Please don't guess what 13 squared is. If you're not sure, multiply it out separately, because I had lots of people who just couldn't square 13, which is sad. Well, it's not sad to not be able to square 13 in your head, but it's sad that you didn't write it down and figure it out, because you have enough time to do that and you don't want to be wasting marks when you could be getting it right. So we've now got this. I now want to kind of rearrange that to find out what cosine theta squared is. So the first thing I'm going to do is subtract this across to the other side. So 1 minus 25/169. I can't do this subtraction straight away, but if I replace 1 for 169/169, it's still equal to 1, but it's much easier to subtract 25/169 from it. So I want to do 169 minus 25. I'm not going to risk doing it in my head because I fancy getting full marks on this. So I'm going to do it by hand. 9 minus 5 is 4. 6 minus 2 is 4. 1 minus 0 is 1. So it gives me 144. That's also feeling pretty good because I know 144 is 12 squared, so I'm starting to see a link there and I can feel like I'm getting through to the right answer. So once I've done this subtraction, I have 144 over 169. And let's just kind of copy this through. So that was cos theta squared, cos theta squared. So cos theta squared is equal to this, so I want to square root both sides, and that tells me that cos theta is equal to the square root of 144 over 169. I can square root each of those separately, and it gives me 12 over 13, which is good because that's the answer they told me it should be. Right. The next question, I'm starting to run out of space here. Let me try and move it up so you can still see my working. The next question asks us to find cos 2a. So I'm going to go back to the formula booklet. Here's cos 2 theta. And I can see I've actually got several different formulas here. Now, actually, it doesn't matter which one I pick because I know my sine theta, I know my cos theta, and so, you know, and I know both of the values are definitely correct. Now, if it hadn't been a show that question, if I didn't know my answer to this part was correct, I'd probably be straight away definitely picking this one because that's got a value that was already given to me within the question. But considering both are given, it doesn't really matter. I'm going to pick the first formula for the sake of doing it, but it doesn't really matter. So the first formula is cos 2 theta is equal to cos squared theta minus sine squared theta. Again, I'm just going to take my time here and write out those as things squared. Instead, it just helps me carry on with my working. So cos theta sine theta. And I know cos theta or cos A, it's 12 over 13. And I know sine theta or sine A, it's 5 over 13. So now I can carry on working those. Ooh, that was a subtract. I can carry on working those out. These figures I've actually already had, so it's going to be 144 over 169 minus 25 over 169. And now I need to do 144 minus 25. I'm going to take my time with that. I'm not going to do it in my head and make a mistake. 4 minus 5, not possible. Carry the 1, so I've got a 9 here, a 1 here, and a 1 here. So that's going to be 119 over 169. And that was already equal to cos 2 theta. There's no need to square root it or do anything else there. Right. Next question. Perfect. So this question is about a straight line. It gives us the equation of the straight line. And the first thing it asks us to do is to write down the gradient of the straight line and the y-intercept of the straight line. Now, what do I already know about straight line graphs? I know that when it's in the form y equals mx plus c, then I know that this is the gradient and this is the y-intercept. But it's not in that form, so I can't just straight off from here read off the gradient and the y-intercept. That's okay, I can rearrange this until it's in this form. So I'm starting off with 2x plus y equals 10, and I want it in the form y equals something. So I'd like to have this y by itself and remove this 2x. It's a positive 2x, so I'm going to subtract it. And that means I can write this out as y equals minus 2x plus 10. And when I do that, now I can see my gradient and my y-intercept. Here is my gradient, the number in front of the x. And here is my y-intercept, the number by itself. So gradient, y-intercept. So my answer to the first part is going to be minus 2. My answer to the second part is going to be 10. Okay, the next question says L2 is parallel to L1. What does parallel mean? It means it's got the same gradient. So L2 is parallel to L1 and passes through the point 0, 3. I'm just going to think about where that coordinate 0, 3 is. So it's 0 along on the x-axis and 3 up on the y-axis. That's where 0, 3 is. So actually it's telling me a y-intercept. And then it says, find the x-coordinate of the point where L2 crosses the x-axis. So it's asking for what is this value here where it crosses the x-axis. Now, we're starting to get further through the paper. This is a multi-step problem where I've got to think for myself a little bit. So the first thing I'm going to do is I'm going to write down the equation of L2. That's definitely going to be useful in finding out that x-intercept. So I'm going to write it in the form y equals mx plus c. My gradient, my m, is the same as the one in the first equation because it says L2 is parallel to L1, so it's going to be minus 2x. And then the plus c is the y-intercept. And actually, it's fairly nice in this question. They've already given me the y-intercept. It's plus 3. So this is the equation for L2. But then the question is, how do I find the x-intercept? Well, you'll notice with the y-intercept, it's got an x-coordinate of 0 and a y-coordinate of 3. And it makes sense that that x-coordinate is 0, right? Because if it's going to be on the y-axis, then the x-coordinate has to be 0. And kind of the opposite is true for any x-intercept. If it's on the x-axis, then the y-coordinate must equal 0. So I don't know what the x-coordinate is, but I do know the y-coordinate is equal to 0. And that information, the fact that y is equal to 0, is what I'm going to use to find the x-intercept. So I'm going to substitute y equals 0 into this equation. So now I've got 0 equals minus 2x plus 3. And I'm going to solve it to find x. So I'm going to bring this across to make it all positive. So I've got 2x equals 3. So x is going to equal 3 over 2, which is 1.5. There we go. I'm just going to double check the question as well, because, you know, sometimes it's asking for a whole coordinate and sometimes it's asking for part of it. But this one's just asking us to find the x coordinate, not the whole coordinate. So I'm happy with my final answer like this. Perfect. Next question. Okay. It says the derivative of a function is given by this. The original function, so f, not f dash, not the derivative, but the original function passes through this point here, and it's asking us to find that function. So the conceptual piece of information we need here is that to go from a derivative function to the original function, we should be integrating. And actually, that's where your first mark comes from on this question. So even showing that you know you need to use an integration picks you up 1 mark here. So I'm going to be integrating 2e to the power of minus 3x. And I'm just going to have a think here, because we have 2 different types of integration. We've got definite integration, where we have lower bounds and upper bounds, and indefinite integration. And I need to make a decision now which one's the type that I want to use. Now, I've not been given any bounds. I don't know a lower bound or an upper bound. I know a coordinate, but I don't know a lower bound or upper bound. Also, usually those lower bounds and upper bounds are used to find area, and we're not interested in finding an area. We're just interested in finding the original function. So I'm not going to do definite integration. I'm going to do indefinite integration. So as I work this through, we could, if you're feeling over the top, you could use integration by substitution here, but it's really not necessary because this is kind of one of those ones that we start to recognize, and we can do it by, I call it by inspection instead. So I know when I'm integrating e to the power of something, it should remain as e to the power of that same thing. And if I was differentiating this, I'd be multiplying it by that minus 3. So as I'm integrating it, I want to be dividing by that minus 3 instead. So minus 2 over 3 e to the power of minus 3x. Now, it's if you're not really confident with that, it would be worth differentiating this using the chain rule to check that you get to this. And if you don't, you can kind of play around with it until you do get to this. So think about that as kind of like a backup option to make sure you're going to get that correct. The next thing I'm thinking to myself is, okay, I've done my integration, but I've not used all of the information here because I've still got this point that it passes through. And you know, where do I use that? But actually, we've done this integration. We've not got a full solution here because actually, remember, when we integrate, we have a plus c. And that plus c is something we don't know yet, but we can figure out by using this coordinate. So let me write out what we've got so far. We now know our function of x is equal to minus 2 over 3 e to the power of minus 3x plus some constant. And I also know that this coordinate rests on this function. And so I can substitute this coordinate into this function to be able to find that plus c. So here we know that our x is equal to 1 over 3 and our y, our function value, is equal to 5. So let me substitute that in. So I have 5 is equal to minus 2 over 3 e to the power of minus 3 times 1 over 3 now, plus c. I'm going to take my time with this. I'll leave that 5 there for a moment. I'll leave that minus 2 over 3 there. And I'm just going to multiply minus 3 by 1 over 3, which leaves me with minus 1 plus c. Now here's where you've got to be fairly confident to be able to figure this out, because this isn't completely simple. I mean, I think the first thing I'm going to do is just bring this across to the other side so that I have c equals something. So it's negative. I need to add it across to the other side. And then I'm going to have 2 over 3 e to the power of minus 1 plus 5 equals c. Now, that's okay. It's not a phenomenal answer. I'm just having a quick look at the mark scheme to see if they're happy with that. Actually, they are. Okay. Nope. I was going to kind of do something clever with it, but there is no need, so let's not. So we can leave it like this, but we're not at our final solution yet because it wasn't asking us to find c. It was asking us to say what f of x was equal to. Here, find f of x. So let's go back to it. We knew f of x was equal to this with a plus c. And now I can just replace that plus c with this. You won't get the final mark unless you write out this full final answer. So minus 2 over 3 e to the power of minus 3x plus, and here's my c, 2 over 3 e to the power of minus 1 plus 5. You might have written this slightly differently. If you did, I'll have given you marks for it, so you'll know that this is a totally acceptable final answer. Right, this is where, just to state, we're really getting onto the challenging questions here. So questions 6 and 7 are some of the hardest questions, and you'll have noticed this, right? It was a 5-mark question with not very much scaffolding, and you just had to go for it. The same will be true of question 7. Now, if you're getting to this stage and looking at these questions and thinking to yourself, it's too much, oh God, I have no idea what I'm doing, leave them. So questions 6 and 7 in particular, they're always going to be these kind of crazier, harder going questions. So I would actually recommend kind of getting to question 4, question 5, skipping these two, and then moving on to question 8, which is always easier than questions 6 and 7. And maybe even question 9. Question 9 is usually weird, but okay. And then question 10 is always a crazy question. Right. So let's take a look at this then. Question number 7, I'll go through it in order just so it's easy for you to find your place. So it tells us we have a quadratic function where p and q are positive integers. It tells us that the graph passes through this point here, and it asks us to calculate the value of q. Now, I'm just going to take a think about this. So I've got a quadratic. Let me just sketch this out. I don't know much about it, but I know it passes through the point 60. And let's just take a look at this. It's almost in a kind of factorized form, except there's nothing being subtracted away here. But what we know is this function is going to equal 0 when the two things that multiply it together equal 0. So it'll also equal 0 when x is equal to 0. So here is the other x-intercept. And we don't know whether it's concave up or concave down yet, so I'm not going to try and sketch it yet. But if I know that it equals, that it passes through this point, well, I can kind of figure out that q has to equal 6 to be able to make this bracket something that would equal 0 when x equals 0. Your other option is you could substitute it into this equation. So my first answer is that q is equal to 6. It then tells me that the vertex of the function is this, and it asks me to find the value of p. So let me just write out what I've got so far. I know f of x is equal to p of x multiplied by q minus x. But I don't just know that, because I already know that q is equal to 6. And this is where a lot of people fell down. They were kind of getting here. They already knew q was equal to 6, but they forgot to substitute it in here. Remember, the questions lead into each other. They help you out as you go through. So then what I've got is f of x is equal to p times, let me try that again, p times x times 6 minus x. And now I can substitute in this coordinate. So 3 is my x, 27 is my function value of x, and I can substitute that in to help me find out what p is equal to. So we have 27 is equal to p times 3 times 6 minus 3. So 27 is equal to p times 3 times 3, so p times 9. I can divide 3 by 9, and then I will have that p is equal to 3. Right, so I now know my function looks like this. F of x is equal to 3 times x times 6 minus x. It then asks me to write down the range of f. Now the range of f is all the different y values that it takes. And if I'm thinking about the range of x, I know it's almost like a visual thing, isn't it? It's, where is their graph in the y direction? So I'm just going to quickly sketch out this graph. Now that I know that p is equal to 3, I know that it's concave down. Hang on a second. That is not true. I'm worried I've made a mistake here. Hang on a minute. Let me just check the solutions. Q is equal to 6. P is equal to 3. That's okay. I think I'm just being... okay, sorry guys. Okay, let me tell you my thought process and then you'll know where I was at. So because p was equal to 3, I was kind of thinking that as kind of like that a, that value that tells us if it's concave up or concave down was equal to 3. And if it was positive 3, it should be concave down. But then I was thinking to myself, hang on a second, I know the vertex is at 327, so it's going to be up here. So there's no way it could be concave down. But then I realized we had a negative in front of that x, so that's going to be what affects it. So better to go with the coordinates, I know, rather than kind of deciding whether it's concave up or concave down. There we go. So that's what my function looks like. And it's asking me to find the range. So it's asking me to say, where is their graph in the y direction? And there's graph at every point from this vertex and below. So I need to know what value does it take at this vertex. And the value it takes at that vertex, well, that's at 327. So the highest value our function takes is 27, and then it's everything below it. So the way I would write that is y is less than or equal to, it includes it, 27. There are some different ways you could have written that. There's lots of different answers in the mark scheme, but that's kind of the way that we've discussed together. Right, that finishes off section A. I'm going to take a pause there and make a new video for section B.